I think it has a built-in 30-minute limit. I'll see if I can figure out how to extend that. Okay, so for b, if f of x equals 7x squared, should be minus 3x plus 1, find f of 1 and f of negative 2. Okay. So really all that means is you're going to replace, for a, g of x equals 3x minus 2. G of 2 just remains, you're going to replace x with 2. That's it. Okay, so 3 times 2 is 6, minus 2 is 4. So you know that g of 2 is equal to 4. G of 0, same thing. We're going to replace every x with 0. Which would be negative 2. So g of 0 is equal to negative 2. So even if we decided, okay, we're going to find g of a, all that means is that we're going to replace every x with a. So g of a would be 3 times a minus 2. Same thing. So everything, whatever's in here, you're just going to replace it in the actual equation. Okay. Any questions on that one? All right. Okay. So now for b, move that up a little bit. So we know our f of x is equal to 7x squared minus 3x plus 1. If we want to find f of 1, we just replace every x here with 1. So 7 times 1 squared minus 3 times 1 plus 1. Okay, 1 squared is just 1. So you have 7 times 1 is 7, minus 3, which is 4, plus 1, which is 5. Okay, so we know that f of 1 is equal to 5. Oops, move that up a little bit. Okay, same thing for f of negative 2. Place x with negative 2, so 7 times negative 2 squared minus 3 times negative 2 plus 1. Negative 2 times negative 2 is 4, times 7 is 28. Negative 3 times negative 2 is positive 6, plus 1, which is 35. So f of negative 2 is equal to 35. Okay. So it's just a matter of plugging in whatever's in the parentheses. Okay. Any questions on that one? Okay. Like I said, if you remember going through all this before, we're kind of leading into where it gets a little trickier. We just want to make sure you have a good foundation here first. Plus, it gives you a chance to kind of mess around with the canvas and get familiar with it. Okay. Move this out of the way. Okay, so we're going to look at the domain and range of a graph. You know how to find the domain and range when they give you each individual point, but we're going to look at just the graph and figure out the domain and range from there. Okay, now remember, the domain is just every possible x value. And your range is every possible y value. Okay. So we're going to get our graphs up here. So let's say if our first graph, we have our x and our y-axis. Okay, so this point, let's say that's -3, 1. This point, we'll say that's 2, 4. And this point would be 5, -2. Okay. Now, if you notice on this one, you have the closed circles at the end, which means those values are included. Okay, so your range is just the highest to the lowest. So your range, just between those 2 points, are your possible y values. Okay, so we know the highest point on this graph here is 4. And we know the lowest point on this graph is -2. So your range is actually going to be from should have been a bracket because of the close. From -2 to 4. Now, if those would have been open circles, then you would have had parentheses there. Because remember, the parentheses are the open circles. When you have the closed circles, you use the brackets. Okay, so let's say forgot your domain. Okay, so your domain is every possible x value. Okay. Here you have -3, which is where it starts. And here it goes to 5. So your domain is just -3 to 5. If you pick any x value, at some point, either above or below the x-axis is going to be a y value. So you know you have your domain and range there. Okay. Any questions on that one so far? All right. Okay, so let's say, for example, if we have the graph of absolute value of x. That's supposed to be all the way down to the 0, so. And put the arrows there. Okay. Now the arrows just let you know what's going on forever in both directions. Okay. So you know your range. You know it starts at 0, but the arrow's letting you know that it's going up forever. So we know it's going all the way up to infinity. So every possible y value is either going to be 0 to infinity, one or the other. It's going to be in that range somewhere. Okay, and remember, infinity always has a parentheses because it's never included because it has no actual value. It goes on forever and ever. So it's always going to be a parentheses with the infinity. Okay. Now, if your domain, if you notice, it's going to go to the right forever and it's going to go to the left forever. No matter what, it's going to keep going in both directions. So you know your domain, since it goes all the way to infinity and all the way to negative infinity, is negative infinity to positive infinity. And again, with infinity, you're always going to use parentheses. Okay, so let's do one more example. Draw our X and Y axis here. Okay, and let's say if we just have a straight line going down that way. Okay, so we know the arrows here means it's going to keep going up and it's going to keep going down. So that range is from negative infinity to infinity. Okay. Same thing with the domain. If you notice, it's going to keep going to the left. As it goes up, it's going to go further and further left. As it goes down, it's going to go further and further right. So the domain is negative infinity to infinity. Okay. So graphically, that's your domain and range for that one. All right. Any questions there? All right. All right. Let me see. All right. So, yep, still recording. Good. Okay. So you'll see I kind of left the first day purposely kind of short just to make sure that everybody can ask whatever questions they need to ask. So we're going to, oh, let me turn that off.